Good day, class, and welcome back to your ESI 1 to 4N or your Engineering Mechanics 2 or your Dynamics of Rigid Bodies. And for today's lesson, this is just a continuation of the lesson 6 that we have started last week. So, silly, we're going to discuss the 6.4 and 6.5 lessons no, for the topic. So, before we proceed, let's just have a quick recap of what we have discussed last week. No, so last week we discussed or we introduced the lesson six, basically the planar kinetics of a rigid body. Started by discussing what is moment of inertia, diba? And we discovered that the moment of inertia is computed by multiplying or yeah the it's just the integration of r squared dr, and it's very useful, no, to compute for our moments, no, when we are dealing with the planar kinetics. We also discuss, no, or derive the planar kinetic equations of motion, yung tatlo, di ba? And also we solve quite few problems involving um, uh, moment of inertia and equations of motion when your body is in translation. So, okay. So, for the continuation nga, no, we are going to discuss the last two parts of this lesson 6. And it composes the equations of motion when your body is in rotation about a fixed axis. No? And equations of motion when your body is in general plane motion. So, recalling sa module 4 natin, no, we did learn there na may tatlong types of planar motion, di ba? When we are dealing with planar motion, meron talagang may exist na translation, rotation about the fixed axis, and the general plane motion. So, paano ba yun i-deal, no? Mga problems na involving sa planar kinetics natin. So, for our first lesson today, or yeah, first lesson is about the rotation is about the axis, and we have a two learning outcomes for today's lessons also. So discuss the principle of equations of motion and planar kinetics using the principle of rotation about fixed axis and general plane motion. And di mawawala, solve problems related to equation of motion, planar kinetics, the rotation about the fixed axis, and the general plane motion. So to start with, the equations of motion when your body is in, when your planar motion is rotation about a fixed axis. Okay. So rotation about the fixed axis is kind of familiar na, diba? Since we already discussed this on module 4. But here is kind of different thing, but yeah, related pa rin sa na-discuss natin sa module 4. Anyways, so consider the rigid body or slab shown in the figure. Eto, no? Which is constrained to rotate in a vertical plane about the fixed axis, perpendicular to the page and passing through the point. Oh, okay. So, ito yung slab natin, which is constrained dito sa pin natin. And it will rotate daw, let's say, counterclockwise kasi sinasabi ng mga arrows dito eh. So, the angular velocity and angular acceleration are caused by the external forces and coupled moment system acting on the body. As you can see here, meron mga force 1, force 2, force 3, force 4. So, and meron din tayong mga moments present on our body. So, yeah, it will be expected na magro-rotate talaga siya, no? About a fixed axis since it is constrained on a fixed pin, no? So, since the body's center of mass, G, moves around a circular path, no? Circular path kasi nga, fixed axis yung nare-rotate niya. So, it will move talaga in a circular path, basically. So, the acceleration of this point is best represented by its tangential and normal components, and we all know that when we are dealing with circular path, meron talagang tangential and normal components. So, what about it? So the tangential component of acceleration has the magnitude of a sub g sub t, or the acceleration. Tangential component of acceleration is equal to the alpha, or the angular acceleration, times the r sub g, or the distance from the fixed point to the g, or the center's mass. No? So, again, medyo ano na to, di ba? Medyo familiar na talaga. So again, the tangential component of acceleration is computed by multiplying the angular acceleration and its distance from point O. No. So it must act in a direction which is consistent with the body's angular acceleration. Kumbaga, yung tangential acceleration mo dito must act consistent sa kung saan yung pupunta yung angular acceleration natin. Kumbaga, dito, our angular acceleration pointed to move counterclockwise. So, ganun din yung tangential component ng acceleration natin sa ating slab. Okay? So how about the normal? So normal component acceleration or the magnitude of the normal component acceleration is computed by a sub g sub n is equals to the angular velocity squared r sub g. So again, this is already familiar kasi nga we did this introduce this one sa module 4. Anyways, let's just review this. To compute for again for the compute for your magnitude of the normal component of acceleration when your body is moving in a circular path. So it must be computed by multiplying the square of the angular velocity and the distance between from the fixed point O to the center's mass. Okay? So this component is always directed from point G to O regardless of the rotational sense of angular velocity. No? So yun nga, when we say normal component directed talaga towards the point O, to the center of the rotation. So expected na dito. Ito, sa bottom part of the figure, as you can see, yung direction ng normal component natin is papuntang point O. Okay? So to obtain the equations of motion, consider the free body diagram and the kinetic diagram shown in the figure. Ito yung free body diagram niya, and this is the kinetic diagram. Okay? So let's discover what are the equations of motion when your body is in rotation about the fixed axis. So the two components of mass times, basically this is the force, no? So the two components of the forces, you have the tangential component and the normal component of the acceleration. So dalawa din yung forces na nag-act dito when we uh, consider the components of the force. So shown in the kinetic diagram, as you can see here, dalawa are associated with the tangential and normal components of acceleration of the body's mass center G. Okay, as you can see here, meron tayong mass times acceleration or mass times the tangential component of the acceleration and another force caused by the normal component of the acceleration. Okay? So the I sub g times the alpha vector acts in the same direction as a or the acceleration and has a magnitude of I sub g, no, times angular acceleration. So that's your moment kumbaga sa ano natin kumbaga sa body natin, it's just the moment. Okay, and it is computed if you're dealing with the moment of inertia, then you just have to multiply the angular acceleration and the moment of inertia so that you can have your moment. Anyways, so for R sub g, it is the body's moment of inertia calculated about an axis which is perpendicular to the page and passes through G. And your angular acceleration, this is your alpha. Okay? So thus the equations of motion of the body that rotates about the fixed axis are first, you're at your normal component or the normal force or normal component of the force, we have the summation of all forces, the normal component of the forces we have is equal to mass times the acceleration, or the normal component of the acceleration is equal to the mass times angular velocity squared times r sub g. Okay, this is your first equation of motion when you're dealing with the rotation about the fixed axis. Okay, so for your next equation of motion, we have your all forces acting, so the tangential component we have is equals to the mass times a sub g, or the tangential component of the acceleration is equals to mass times the angular acceleration times r sub g. Okay, for the last equation of motion, we have all moments at point E. The summation of all moments at point G is equals to I sub G times angular acceleration. Since this is the only one acting on our body. So based on our kinetic diagram, di ba? So forces na nag-act sa normal component, there's only one. We have the M times A sub G sub N. And for our tangential component naman, meron din isa. So, ganun lang. And then, for our moment, isa lang din yung moment dito. So, we have that will be equal to I sub G times alpha. Okay? So, the moment equation, no, you have the summation of all moments at point G is equals to I sub G times alpha can be replaced by a moment summation about any arbitrary point P on or off the body provided one accounts for the moments, no? Summation of all the kinetic moments at point P produced by I sub G times alpha, mass times or the force or tangential component of the force and the normal component of the force about a point. So bakit ba natin ginagawa to? So sometimes we need to discover any type of solution na pwede natin i-eliminate yung isang unknown, di ba? Or hindi lang isa, but uh, dalawa or something like that. So we're going to set our point on a point sa body na mayroong makacancel or hindi na natin kailangan i-consider since wala siyang moment arm. But anyways, this is to introduce another type of solving when we are dealing with rotation about the fixed axis. Again, the moment equation, etong moment of equation na to, can be replaced a moment summation about the kasi eto, ano to eh, sa centers, body centers of mass, diba? Center of mass, diba? So, sa G, at point G. So, pwede tayo mag-assign ng points dito or somewhere here so that we can cancel out a force, force ba ngayon or a moment, no? To simplify our moment of equation. So, ganun lang yung point dito. But anyways, we have related tayo neto further or later on. Okay? So consider point O at located at point at the pin of the body shown in the figure. Ito. So consider itong point na to. Kumbaga ito yung ano yung moment of equation about point O. So ano yung mga moment of equation na pwedeng gamitin natin solving at point O. Okay? So to obtain the moment equation, we will sum the moments about pin at O to eliminate the unknown forces F sa O. Diba? Kung meron tayong, kunwari, if we are summing all of the moments at point G, so, dating sa point na kailangan itong i-consider to. Di ba? Kasi meron tayong moment arm dito away from our point G, di ba? So, kung sa point G lang natin, mawawala tong weight, no? Di ba? Kasi we are considering the summing of all the moments at point G. So, at point G, ito lang, weight lang yung mawawala since wala siyang moment arm, so wala siyang moment. Pero if we are considering at point O, etong force sub O or F sub O will be cancelled out or ma-eliminate when we are summing all of the moments. Okay? Just ito lang yung yung point dito. For anyways, applying summation of moments at point O using the FBD and kinetic diagram, ito. So, summation of all moments at point O is equals to the summation of all the kinetic moment at point O as well. No? So, with that, it will be equal to the summation of all the moments in point O is equals to the moment. So, ano yung mga summation na nandun sa kinetic diagram natin? So, as we can see here, at point O, ang mawawala lang dito is yung M. Consider natin tatlo dito, di ba? Initially, as we can see here, meron tatlong um, external forces and moments na present sa body natin. But, na-consider lang natin yung tangential component ng force natin since it has a arm of R sub G, di ba? And I sub G times alpha is already a moment, so we can just add it up directly. But for our the tangential component, no? Times lang natin doon sa moment arm niya for away from point O, then we can have it here. But as you can observe here, sa normal component, note that the moment of the normal component m times a sub g sub n is not included in the equation 6.4.4. Why? Because the line of action of this component passes through point O. Di ba? Wala siyang, kumbaga, yung moment ng line of action niya is nag-pass sa point O. Therefore, wala siyang moment doon. So, wala siyang na-contribute ng moment when we are summing all of the moments at point O, di ba? So, the kinetic moment, as we call it. So we can further simplify equation 6.4.4 by substituting a sub g sub t by its angular acceleration times r sub g and apply parallel axis theorem. So again, we already discussed this one previously sa lesson natin. So let's simplify this equation. Okay? Sabi doon, yung a sub g sub t natin, it will be replaced by its angular acceleration or alpha times r sub g, since this is equivalent to a sub g, as we all know. So summing of all the moments at point O is equals to the mass times the angular acceleration times r sub g times r sub g plus I sub g alpha. Okay? So therefore, the summation of all the moments at point O is equals to the alpha times m times r sub g squared plus I sub g. Now, here, ano lang natin, nilabas lang natin yung, ano natin, factor out natin yung alpha or the angular acceleration so that we can have this final or simplified equation for our summation of all the moments. Okay? So, applying a parallel axis theorem with respect to point O, I sub O is equals to I sub g plus md squared. Diba? So, where d is equals to r sub g, since pareha lang naman yun kasi nga at point O, yun din yung parallel axis theorem from our sub G. Kasi diba? Away from, parallel siya sa point G or centers, body centers of mass, yung point O. So we can use parallel axis theorem. So parallel axis theorem says that I sub O is equal to I sub G plus md squared, or the mass times the distance between the points, square that one, and then you can have your moment of inertia at that point, at any point. Okay? So, mas simplify pa natin to. Therefore, magiging ano siya? I sub O is equals to I sub G plus M R sub G squared. From MD squared, naging R sub G, since we said that D is equals to R sub G. So, substitute lang natin yung equivalent ng D sa R sub G. Okay? And this one is kind of identical for this one. So, therefore, we can simplify that one into, from this, I sub g plus mr sub g squared times alpha. And that will be equal now to summation of all the moments at point O is equals to I sub O alpha. Or if we read this technically, is summation of all the moments at point O is equals to the moment of inertia at point O times the angular acceleration. So, ganun na kasimple. If you already have the given, no? Given na yung point O, ano yung moment of inertia at point O, then multiply mo lang dun sa acceleration, then you can have your unknowns na kailangan mong kunin. Okay? So, thus the three equations of motion of a body that rotates about the fixed axis are, first, for your normal component, for your tangential component, that will be m times alpha times r sub g. And for your moment, there's the third equations of motion is the summation of all the moments at point O is equal to I sub O times alpha. Okay? So that's your three equations of motion, no? So moment equation of about point O. Note that when using equation 6.4.7 moment equation, remember that I sub O alpha accounts for the moment of both tangential component sa force and the moment acting on our body, which is equal to I sub g times alpha about point O. Okay, take note class that I sub O is not actually direct na kailangan, paano mo compute yung I sub O is not readily, compute mo na talaga directly. So, meron siyang dalawang component, yung tangential component ng force and your moment na nag-act sa body natin, which is equal to I sub g times alpha. Okay? So, in other words, the equation can be Eto. So, summation of all moments at point O is equals to the summation of all kinetic moment at point O is equals to I sub O times alpha. So, this is the moment of inertia at point O times the angular acceleration. Okay? So, let's have a procedure of analysis so that we can have all, and then you can have a uniform, procedure to solve for a problem when we're dealing with rotation about the fixed axis na equation of motion. So, ano bang dapat natin gawin? First, identify the given and announce the problem, of course. It's your first thing to do. Next, if you already identify those given and announce, establish the inertial and subt coordinate system and specify the direction of the sense of acceleration a sub g sub n and a sub g sub t in angular acceleration of the body. Okay? So, establish the inertial coordinate system. Katapos mag-establish ng inertial coordinate system, tangential component must act in a direction which is in accordance with the rotational sense of angular acceleration. Take note class ha. Pag nag-establish ka ng inertial coordinate system ng components ng acceleration mo, yung a sub g sub t must be in a direction na accordance with the rotational sense ng angular acceleration mo. This is alpha. This is not A, but alpha. Okay? Take note that one. So, while the normal component always acts towards the axis of rotation. So, kung saan yung center of rotation mo, dun din yung axis or the direction of your normal component. Okay? So, next is, after you draw or you establish your inertial coordinate system, of course, hindi mawawala yung FBD mo in order to account for all the external forces and coupled moments that act on your body. Okay? Next is if the rotational equation of motion, no, summation of all the moments at point P or any point is equals to the summation of all the kinetic moment at point P also to be used in solution. Draw the kinetic diagram in order to help visualize the moments developed by the components m times a sub g sub t, m times a sub g sub n, and the moment I sub g times alpha when writing the terms of the moment summation of all the kinetic moments at point P. Okay? So that after mo mag-draw ng FBD, now, since meron tayong third equation of motion na kailangan natin i-consider then when we are solving a problem, no, we need to draw as well the kinetic diagram para ma-visualize natin na ano talaga yung mga moments na nag-act developed by our components sa tangential and the normal and also the isob terms alpha. Di ba? Nasa natin figure kanina from FBD may katumbas na kinetic diagram. So, important din yung kinetic diagram so that you can visualize kung ano yung mga moments na nag-act sa body natin. Okay? So, next is apply the three equations of motion of the body that rotates about the fixed axis in accordance with established sign convention. Kung gusto mo positive yung clockwise mo, then you can go for that, or the opposite, then you can go for that also. Next is after apply the three equations of motion, eto, you have the normal component, which is equals to m times angular velocity squared times r sub g. For the tangential component naman, we have m times alpha times r sub g. And for the moments at point G is equals to r sub g times alpha. Or at point O naman, if ayaw mo dun sa center of mass, no, then you can have this one any point or at point O, then you can have it by summation of all the moments at point O is equals to the moment of inertia at point O times the angular velocity. Eto. Okay. If moments are sum about the body's mass center G, use the summation of all forces at point G is equals to I sub G sub times alpha because m times a sub G sub t and m times a sub G sub n has no moment at point G. So, kung gusto mo ganyan, para wala kang ano, say, um, walang problema, no? If you're going to get this one since uh, para wala ng ano ba, wala ng moment na nag-cause sa tangential tsaka ano mo, normal, then you can have your point at point G or the plasma center so that ma-cancel or ma-eliminate natin yung tangential and the normal. Baga, yung moment na lang na nagkakos ng ano mo, rotation doon or the moment is only the I sub G sub A. And we can already solve this one. Okay? So if moments are sum about pin support O on the axis of rotation, use summation of moment at point O is equals to I sub O times alpha, where I sub O is again is equal to I sub G plus MRG squared. And note that the normal component has no moment at point O kasi nga yung line of action yan nag-pass through sa point O natin. So wala siyang M times A sub G sub N. So ito lang yung ino-note mo when you're using or kailangan natin mag-sum ng mga moments at point O. Then the only thing we have to consider is wala siyang normal component and your I sub O is equals to I sub G plus MR sub G squared. Then this is derived again from our parallel axis theorem na introduce natin last one. So if the angular velocity and angular position of the body is required in the problem, apply the concepts of kinematics, rotation, and abutment axis formula. If the angular acceleration is variable, then you can use this one and this also, and you can use this as well. Okay? Kung kailangan ng ano ba, pag tinanong ko ng problem, what is the angular velocity of our problem, then use this one. If variable yung angular acceleration. Now, if constant, if angular acceleration is constant, you use this one. So we have your angular velocity is equals to initial angular velocity plus a sub c times alpha sub c times t, and so on. Then you can use all this one. So let's have an example. So for example number one, for our rotation about a fixed axis, it says that the unbalanced 50 pounds flywheel shown in the figure below has a radius of gyration of k sub g is equal to 0.6 feet about an axis passing through its mass center G. Again, nagpass through sa center G, so we can call that K sub G. So, zero point 0.6 feet daw siya. So, it has a mass, I don't know, it passed through its mass center G. Now, if it released from rest, again, take note, if it is released from rest, determine the horizontal and vertical component of the reaction at pin O. So, ano yung mga reaction dito? Di ba kay pin man siya? So, meron talaga siyang reactions at vertical and horizontal components. So, paano yun isi-solve? Let's solve this. So, given are the weight of the flywheel is 50 pounds. The radius of the gyration is 0.6 feet. Bakit 0.6? Saka dito. 0.5 lang dito. No. 0.6 nga. 0.6 feet. And R sub G, or the radius from the center of body, but the center of mass to the point O is 0.5 feet. And the required are the horizontal component, the vertical component, and angular acceleration. Okay. So first, construct the free body diagram and kinetic diagram to show the forces or reaction that acts on the body. So, yung FBD niya, ito. So, again, meron reactions sa point O natin or sa our support or our pin. Meron siyang normal and tangential. So, kailangan natin i-account yan. That's another forces na nag-act sa flywheel natin. And it's, of course, yung weight. So, it's weight. We have 50 pounds. And I think that's all the forces. And for the kinetic diagram naman, we have our di mawawalang moment na I sub G times alpha and mass times alpha times R sub G. Yan. Next, consider both the normal tangential components of acceleration since the body moves in a circular path. So we need to consider the normal and tangential kasi nga nag-rotate siya in a circular path. So for the moment, of inertia about point G. So, paano ba isolve natin yung I sub G natin dito? Given yung radius of gyration. So, we already know how to solve for our moment of inertia at point G using the radius of gyration. We have mass. We have only to multiply the mass and the radius of gyration, square that one, so you can have your I sub G. And mass is equals to the weight over the gravity or acceleration due to gravity times the radius of gyration square. Okay? So our weight is 50 pounds and our acceleration due to gravity is 32.2 feet per second squared, and our radius of gyration is equals to 0.6 feet squared. Therefore, our I sub G, or the moment of inertia at point G, is 0.559 slug feet squared. Okay, so applying equations of motion, we have for our normal component, it will be equal to zero since the angular velocity is equal to zero since it is released or it was released from rest. Therefore, your O sub n, or the normal component or the normal component of the reaction at point O, is equal to the mass times the angular velocity, which is equal to zero since it's released again from rest. Square that one times r sub g. Therefore, your reaction, or the normal reaction of at point O, is equal to zero. So that's your first unknown. Next is the summation of all the forces at tangential component, where your positive sense will be your downward, though be equal to mass times angular acceleration times r sub g. So therefore, yung mga vertical na mga na forces is O sub t and the weight. So that will be negative O sub t plus 50 pounds. Okay? Negative kasi nga pa-upward yung natin, O sub t. And is equals to the mass, again, weight over g times angular acceleration times r sub g, or 0.5 feet. Therefore, your angular acceleration is equals to 50 minus O sub t over 0.7764. So that's your equation 1, since that dalawang unknowns dito. So we need another equation. But there's one equation of motion, which is the sum of all the moments at points G. So that will be equal to I sub G times alpha. So the moment at yung moment lang na nag-a-act sa natin sa kinetic diagram, based on the kinetic diagram at points G, is only this one. So that would be, or your O sub T times 0.5 feet. Kasi nga, yung tangential, again, when we are summing all of the forces sa point G, yung tangential at point O, rather, is yung tangential lang and walang normal component. Therefore, O sub T times 0.5 feet is equals to I sub G times alpha. Diba? Ito lang yung nag-act dito. Yung MA, or M alpha r sub G, that will be equal to 0.5559 slug feet per feet squared times angular acceleration. So again, yung moment na dito sa point G natin is only the O sub T. Again, kasi nga, yung O sub N, yung radius niya, or the torque arm or the moment arm is wala. Kasi nga, line of action is passing through the center of mass, G, and yung weight natin is nawala since andun tayo nag-moment, so walang weight doon. Then the only force that causing our body to rotate is only the O sub T, and therefore, consider natin for all those moments at point G, it's only O sub T, so that will be times 0.5 feet is equals to 0.559 slug feet squared times alpha. So solving for our equation 2, so that will be 0 t, or 0 sub t is equals to 1.118 alpha. So substitute lang natin yung equation 2 sa equation 1 natin. So to solve for our alpha, therefore your alpha is equals to 50 minus O sub t over 0.7764. And then, substitute lang natin yung value ng O sub t natin na nasolve natin sa equation 2. So that will be 50 minus 1.118 alpha over 0.7764. Therefore, our angular acceleration is equals to 26.39 rad per second squared. So that's your answer for our required or unknown sa letter C natin. So hindi pa natin na-solve yung O sub t natin. So since we already have for our angular velocity, then we can solve for our O sub t using the equation 2. Di ba? So solving for our O sub t or the reaction or tangential reaction or tangential component of the reaction is equals to 1.118 alpha is equals to 1.118 times 26.39 rad per second squared, which is our alpha. Therefore, our O sub t or our tangential component of the reaction is equal to 29.51. So that's how you solve for our this problem in this way. But there's another way of solving this one. So there are also other ways to solve for angular acceleration. So paano ba natin i-compute yung angular acceleration using other um way, as we all know for our what we have discussed kanina. So first is by applying rotational equation of motion about point O. So ano ba yung mga rotational equation of motion doon sa point O natin? So at point O, we have to summation of all the moments at point O is equal to the kinetic or summation of all kinetic moments at point O. So that will be equal to 50 pounds. Kasi nga, dito tayo nag-moment, di ba, sa O. So only the weight of the body causing the body to rotate. So therefore, 50 pounds, zero point 0.5 times zero point 0.5 feet, that's the only one, that's the only force that will be considered. Is equals to the summation of all the kinetic moments. Based on the kinetic diagram, meron dalawa. That will be I sub g times alpha and the m times alpha r sub g. Diba? Ito lang yung dalawa. Therefore, i-times mo lang sa moment arm niya for away from point O. Therefore, that will be r sub g. Okay? So, therefore, that will be 50 pounds times 0.5 feet will be equal to 25 times the solve for r sub g using the radius of gyration is mass times k sub g squared times alpha plus m times r sub g squared to class squared. Okay? So that would be 25 is equals to 50 pounds over 32.2 feet per second squared times yung radius of gyration natin is 0.6 feet squared times alpha, that will be your unknown, and then 50 pounds over 32.2 feet per second squared alpha times the 0.5 feet times 0.5 feet. Therefore, your angular acceleration will be equal to 26.39. So, we solve it directly. Hindi na natin kailangan ng dalawang equation to solve for our angular acceleration. Diba? So, that's how you solve for if yung nag-apply tayo ng rotational equation of motion sa point O. Ito yung pag-solve natin using the equation of motion at point O. No? Kanina at point G man kasi yun. So, yeah, na-solve natin yung normal component ng reaction and then the tangential component of the reaction, and we also solve for our angular acceleration. Now, for this way naman is consider natin yung moment at point O. Then, as we use the rotational equation sa moment at point O, then we solve for our angular acceleration. Now, second is by summing moment about point O and apply parallel axis theorem as we all derived kanina. So, how to apply this one on this problem? So, summation of all the forces, summation of all the moments at point O is equal to I sub O times alpha, where your I sub O is I sub G plus MR sub G squared, or your I sub G is MK sub G squared plus MR sub G squared. So that will be I sub O is equal to 50 pounds over 32.2. That will be your mass times 0.6 feet squared. This is your I sub G plus mass 50 pounds over 32 feet per second squared times K sub G, that will be 0.5 squared. Therefore, your I sub O is equals to 0.9472 slug feet squared. Therefore, then summing moments That will be eto. So 50 pounds times 0.5 feet is equals to 0.9472 times alpha. Therefore, masolve na natin yung alpha as 26.39 rad per second squared. Medyo madali-dali lang, di ba? Eto, when we are using the summing moments about point O and apply the parallel axis theorem, di ba? We just solve the I sub O, then consider yung sum of all the moments at point O, then it's only 50 pounds times 0.5 feet. Divide mo lang yung I sub O, then you can have your angular acceleration, your alpha. Medyo madali na lang. So that's how you solve for your or for this problem. I hope you did learn something. So next lesson is your equations of motion and general plane motion. So ano naman tong general plane motion, no? So as we all know, sa module 4 natin, we did mention there na yung general plane motion is the combination of the translation and the rotation about the fixed axis. So, yeah, expected talaga na medyo um, tricky ang general plane motion. But anyways, recall on module 4 that a general plane motion is a combination of translation and rotation about a fixed axis. Ganun talaga yun. Thus, we need to apply the equation of motion for translation. Again, equations of motion sa translation and the equation of motion sa rotation about the fixed axis. So, dalawa yung i-consider natin dito. Kasi nga, yung body natin is nag-translate tas nag-rotate about sa fixed axis. So, consider the rigid body shown in the figure. The body is subjected to general plane motion caused by externally applied force and coupled moment system. So, again, meron tayong mga forces and then moment of coupled moment system dito. So, meron tayong A sub G, meron tayong angular velocity, meron tayong angular acceleration, meron tayong mga forces, and all of the moments are exerting on our body. So, paano ba to? So, the free body diagram and kinetic diagram for the body is shown in the figure. Ito yung mga, free body diagram ng natin kanina. Ito. Kumbaga, ito yung natin, figure, or ito yung slab natin, or the rigid body. Ito naman yung free body diagram niya. So, meron tayong weight, meron tayong mga forces, and inertial, natin, coordinate system. So, meron tayong y-axis and x-axis. So, the free body diagram is shown nga dito. So, if an x and y inertial coordinate system is established as shown, the equation of motion are this one. Okay, so we have all forces along x, that will be mass times a sub g sub x. Diba? Again, all of the forces along x will be equal to equation of motion when we are dealing with translation. Ito yung gagamitin natin. So at forces along y naman, we have acceleration along y. And then for our moment, or summation of all the moments at point G, that will be I sub G times alpha. Okay? Next is in some problems, or in some cases, it is convenient to sum moments about a certain point, say P, other than mass center G, because it eliminates as many unknown forces as possible from the moment of summation. Diba? As we all discuss kanina na pwede natin mag-allocate or uh, mag yan nga, magmo-moment tayo sa certain point or any point. Kaya nasa point O kanina. So, meron mga forces na ma-eliminate. Di ba? So, ganun din yung medyo convenient na gawin when we are dealing with this kind of problem. So, kailangan natin allocate or natin, as a certain point, no? To eliminate some forces. So, in this case, the sum of moment equation will be, ayan. So, summation of all the moments at point P or any point, no? And at any point of our body here, then equal mo lang doon sa summation of all the kinetic moment at point P as well. Okay? So, an equation above, summation of the kinetic moments, point P, represents the moment sum of I sub G times alpha and mass times the acceleration at point G or its corresponding components about point P as determined by the data on the kinetic diagram. Ito, kumbaga. Okay? Again, yung summation of all the kinetic moment, ang mga kinetic moment dito is yung ito, force along y and x, and also this one, ito yung mga consider natin. Or the resultant force of the two components, we have m sub a sub g. So, yeah. Yung, ayun nga, represents the I sub g times alpha and ma sub g. Yung summation of all the moments at point P. So, ito lang dalawa kung consider mo. Okay? So, moment equation about I sub IC. Ano ba itong IC? So, there is particular type of problem that involves a uniform disk or a body of circular shape that rolls on a rough surface without slipping, as shown in the figure. Ito commonly, pag when we're dealing with general plane motion, ito yung makakita mo or mga common problems na madideal mo when we are talking about general plane motion. So, about IC, ito yung IC natin. Okay? So, if we sum the moments about the instantaneous center of zero velocity, then the kinetic of all kinetic moments, so summation of all the kinetic moments at point IC becomes I times IC alpha. Diba? Ito lang naman yung moment na kailangan natin consider natin dito, which is yung angular acceleration tas yung force. Or yung moment of inertia mismo sa disk natin or itong circular shape na to. So, yung summation of all the kinetic moments at point IC, that will be I sub IC times alpha. Thus, your summation of all the moments at IC is equals to I sub IC times alpha. Okay? Ito lang yan. Okay, so common example of this, common example sa mga moment about about IC, ito mga IC na to. So, which is a soil compactor. Ito yung soil compactor natin or commonly mga type of soil compaction ng mga machines or yeah, like mga pison, mga ganun ba na mga trucks or vehicles or ano tawag. So, as a soil compactor or ship's foot roller moves forward, the roller has general plane motion. So, ayun nga. Nag-rotate siya na about the fixed axis, tas nag-move siya, and translation na siya ng either na-curve na path ba or rectilinear na path. So, yeah. Best example talaga dito yung ito, soil compactor, yung mga pison-pison na yan. When we are talking about general plane motion. Okay? Again, nag-rotate siya fixed axis, tas nagtatranslate siya at the same time. So, that will be that will be considered as general plane motion. So, the force is shown in its free body diagram. Example, ito yung roller niya sa ano natin, so compactor. Ito yung mga forces na nag-act doon. You have your weight, yung component ng natin, reactions sa center or body center of the roller. We have G sub X and G sub Y. We have also the normal force na na-exert sa weight natin. So there's weight, there's also the normal component. Then you have your force. Ito yung kumbaga yung slipping bakan or the force or the friction between the roller and the soil or any other type of ground. So, ito din yung kinetic diagram niya, which is the I sub G I sub G alpha is the moment. We have also the M times A sub G, then also the point A, we have your D, or the radius of the roller. Then this is your kinetic diagram. So, ano bang meron dito? So, if the moments are summed about mass center G, ayan, so we have summation of all the moments at point G is equals to I sub G times alpha. However, if the moments are sum about point A, or then IC, or katawag nila ditong IC, wala tayong magagawa doon. So, anyway, at point A daw, however, if the moments are sum at point A, ayan, ano mangyayari? So, I sub A yung i-consider natin. Kumbaga magagamit tayo ng parallax theorem again. We have I sub G times alpha times M times A sub G D. Diba? D squared to dapat eh. Summation squared dyan when we are going to use parallel axis theorem sa I sub A natin dito. So that meron tayong mga cancel ng mga forces. Ito yung weight, your normal component, no? Yung mga ano na lang, yung G sub Y. So marami talagang ma-cancel out or ma-eliminate ng mga forces. For anyways, when we are we're going to some of the moments about point A, ito yung ano niya, moment equation of motion. So we have all moments at point A is equals to I sub A times alpha, which is equals using parallel axis theorem will be I sub G times angular acceleration plus mass times the acceleration times d or the distance between them squared. Okay? So procedure analysis, meron tayong procedure analysis again. So we have to identify the given and announce the problem. Okay, that's 2 points. Anyways, establish next after you identify those, we have to establish the inertial coordinate system. Okay, and draw the free body diagram for the body to show all the actions of the forces. Specify the direction and sense of the acceleration of the mass, center, a sub g, and angular acceleration, alpha, of the body. And determine the moment of inertia about mass, center g. Okay? Alam na natin yung paano pag-solve ng I sub g ha. If we're going to use the inertia of gyration, yung mass niya mismo, yung distance na about the point G. So that's how you solve for I sub G. Okay? Next, after you determine the MOI ng at point G mo, then if the rotational equation of motion or summation of all the moments at point P is equals to summation of all the kinetic moments at point P as well is to be used in the solution. Draw the kinetic diagram in order to help visualize the moments developed by the component m times a sub g sub x, m times a sub g sub y, and I sub g times alpha when writing the terms for the moment of sum at point P. Okay? So, kung gagamit ka ng kinetic moments mo, then you can draw your kinetic diagram so that it will help you to visualize the moments developed by the components. Okay? Again, next is apply the three equations of motion in accordance with established sign convention. Okay, so that will be summation of all the forces along x. That will be mass times acceleration sub or along x-axis. Then summation of all the forces along y. That will be mass times a sub g along y. Then all moments at point G, then it is equals to the moment of inertia times alpha. Okay? So if the angular velocity and angular position is required in the problem, then if angular acceleration is variable, then you can use this equations. Then if the angular acceleration is constant, then you can use this mga formula na to. Okay? If kailangan ng problem ng angular velocity and angular position. Okay? Then you can use all these formulas. So let's have an example. So determine the angular acceleration of the spool shown in the figure dito, hindi siya bulong. So the spool has a mass of 8 kilograms and radius of gyration that will be 0.35 meters. The chords of negligible mass are wrapped around its inner hub and outer rim. Okay? Ang tanong is determine the angular acceleration. So, paano ba natin i-solve yan? So, determine the or identify the given and the required or the unknowns of the problem. So, given niya is yung figure and the mass ng spool natin is 8 kilograms and the radius of gyration is 0.35 and the required value of the problem is angular acceleration of the spool. Okay. So, again, draw the free body diagram and the kinetic diagram to show all the forces. Excuse me. So that will be draw the free diagram and kinetic diagram. So that will be FBD and kinetic diagram. So, ito yung FBD niya and it's the kinetic diagram. Again, meron tayong 100 Newton dito and the tension of the cord and the weight of the spool. That will be 78.48. Multiply mo lang yung 9.8 and so on. And we have here 0.980 kilograms meter squared times alpha and the distance of the point A. If ano natin dito, gagamit tayo ng summation of all the moments at point P or point A. So, ito yung kinetic diagram niya. So, as shown in the body's FBD and kinetic diagram, the 100 Newton applied force caused A sub G to act upward and angular acceleration to act clockwise. No, nang dahil dito sa ano natin 100 Newton, pa-upward yung ano natin, movement ng acceleration natin and the angular acceleration will be clockwise. So since the cord is wrapped around the spool. Okay, so first I sub G, then apply the equations of motion. So let's solve for I sub G using the radius of gyration. So that will be I sub G is equals to M times K sub G squared, that will be 8 kilograms, times 0.35 meters squared. So that will be 0.98 kilograms meter squared. So dito yung nanggaling. This is I sub G, okay? So summation of all the forces along Y is equals to mass times A sub U times sub Y. That will be the tension of the cord plus 100 Newton minus the weight. Ito yung mga forces na, mga vertical forces na nag-act sa body natin. So that will be 3, tension, 100 Newton, and the weight. And we also assume the positive sense of the forces. That will be positive yung upward. Okay, that will be tension is upward. 100 Newton will be upward. That will be positive. And since the weight is downward, then that's negative. So that will be mass times acceleration. That will be A sub G times 8 kilograms. So T plus 100 minus 8 kilograms and 9.81 meters per second squared. That will be 8 times A sub G. So your first equation, that will be equal to T is equals to 8 times A sub G minus 21.52. This is your first equation. So next equation naman. So summation of all the moments at point G is equals to I sub G times alpha. That will be ano yung mga forces na nagkakos ng moment dito sa body natin. That will be 100 Newton. Distance from the center is 0.2 meters. So 100 Newton times 0.2 minus the tension. That will be counterclockwise. So that will be negative. So T times the distance from the center is 0.5, so equal to I sub G alpha. So I sub G natin is na-compute natin na 0.98. So our second equation will be equal to T is equals to 4T minus 1.96 alpha. And since A sub G is equals to A sub R, we already know this one, di ba? Times mo lang yung radius na ano natin sa angular acceleration, then we can have our acceleration. So therefore, we have your A sub G is equals to alpha point times 0.5. That will be our equation 0.3. Kasi ang given dito is angular acceleration. But we need the acceleration. Di ba? So that will be substitute equation 3 to equation 1. That will be T is equals to 8 times A sub G minus 21.52. Then A sub G is equals to 0.5 alpha. So T is equals to 8 times 0.5 alpha minus 21.52. So that will be your equation 4. Para alpha na talaga yung alpha and tension talaga yung dalawang anons natin. Okay? So substitute equation 4 to equation 2, then we can have our tension. T is equals to 4T minus 1.96 alpha. And for our T is equals to 4 alpha times 21.25, that will be 4 times alpha minus 21.25 is equals to 4T minus 1.96 alpha. Then we can solve for our angular acceleration will be 10.28 rad per second squared. So this is how you solve for your angular acceleration. Okay, no, the transition from acceleration, then convert natin to angular acceleration. as yung nalaman natin, di ba, acceleration is equals to angular acceleration times the radius of it. Then you can have your angular acceleration. So, pag solve natin, kinuha muna natin to be homogeneous yung mga unknowns natin from the equation 3, di ba? Ang acceleration lang siya. So, kinonvert natin to angular acceleration. Ano ba yung equivalent ng acceleration na to the angular acceleration so that yung dalawang equations natin is ano na, homogeneous siya. Tension and acceleration na relationship. Angular acceleration na relationship. So, after solve natin sa equation 4, then substitute natin sa equation 2, then we can have our angular acceleration. Okay. So, solving for the tension and the acceleration, so substitute mo lang natin yung mga yung angular acceleration na nasab natin, then we can have our tension to be equal to 19.85 Newton. So, how about the acceleration? Now, we can also solve that one kasi meron tayong ano dito. So, that will be the acceleration at point G. That will be 0.5 times 10.28. So, that will be A sub G is equals to 5.14 meters per second squared. Okay? So, angular acceleration alpha can also be solved without considering the announced force T by summing the moments at point A. So, ayun nga, meron din tayong another way of solving for this type of problem. So, mag-sum tayo ng ng moments natin at point A. So, anong mangyayari doon? So, mawawala tong tension. Di ba? Kung mawawala tong tension, the only acting on the body is the weight and the 100 Newton. So, sum natin dito. We have your 100 Newton times 0.2 meters plus 0.5 kasi away from point A, yung 100 Newton is 0.2 plus 0.5. So, that will be your torque arm or the moment arm minus 78.48.5. This is your weight of the body times 0.5 meters is equals to I sub GA or alpha plus M times A sub GR sub G. Ito yung kumbaga I sub G, no, I sub A, no? Summation of all the moments at point A. So that will be the parallel axis theorem, no, I sub G alpha times MA sub GR or sub G. So that will be 70 minus 39.24 is equals to 0.98 alpha plus 8 times 0.5 alpha. So ito yung 0.5 alpha is the mass. That's A sub G, no? Times R sub G kasi nga ang A sub G natin is 0.5 alpha as we all know kanina, di ba? Na na ano natin, na-solve natin yung equivalent ng A natin to alpha, that will be 0.5 alpha times R sub G, that will be 0.5. Therefore, your alpha will be equal to 10.32 rad per second. So, same pa rin sa na-solve natin previously. Okay? So, that's how you solve your angular acceleration using other way by summing the moments at point A. Okay? So, note that A sub G is equal to R sub G alpha. That will be 0.5 alpha. Okay? So another way to solve again the angular acceleration alpha is by realizing that point A is the IC of the Ford spool. Thus, applying the equation, itong equation na to, di ba? So we derived kanina. So that will be a summation of all the moments at point A is equal to I sub G alpha. So that will be I sub G alpha plus M A sub G D. Okay? That will be summation of all the moments at point A is equals to I sub G times alpha plus M times 0.5 alpha is equals to R, 0.5 alpha times R sub G. So that will be 100 Newton times 0.2 plus 0.5 minus 78.48 Newton times 0.5 is equals to 0.98 alpha plus 8 times 0.5 alpha times 0.5. 70 minus 39.24 is equal to 0.98 alpha plus 2 alpha. So that will be A is equal, angular acceleration or alpha is equal to 10.32 rad per second squared. So that's how you solve for your angular acceleration using the IC na way of solving angular acceleration. So I think that's how you solve for your angular acceleration of this problem. So I think that's all for the lesson 6. And if you want some examples, no, I uploaded, there's a folder there or a PDF na andun yung discussion or andun yung mga points there, and then may mga additional na mga examples. And also there are some lecture videos na andun sa folder as well. Okay? So how you did learn something for this lesson, and see you next video or next lesson.